Good morning, folks. Welcome to another Fusion Friday. This is the Fusion 360 model for Keith Fenner from TurnWright Machine Works, Porsche 944. And God bless Keith. He's new to Fusion. We talked about doing this as a collaboration, and then he just did it. And he sent me this model, and I was blown away because Keith isn't a CAD guru or a CAD expert. He's a great machinist, but he's new to Fusion, and this was just blew me away. So Keith, nice job. Unfortunately, it's so good that it's really got me stumped because Keith says, now I want to make the thing. So again, if you saw, we did an earlier video where we started talking about this, but these four plastic pins would kind of push into the dash on his Porsche 944. Here is, I believe this is the factory one, or maybe this was an aftermarket one that he bought as a test fit. And here were his original sketches. So you can see the four holes, or the four legs, and some of the gauges that he's going to put into the one that he's going to make. And then there's the empty cavity, which, again, I don't know what was in there before. Maybe it was a radio. Keith will know. And so, by the way, of course, check out Keith's channel. If you don't know or already subscribed, I absolutely please do. Keith does great videos, and I've really enjoyed and learned a lot from them. And he'll be doing a video talking about how he's going to make this, which I'm going to be pretty blown away to see how he pulls this off. The task at hand today is to help Keith understand the cam. And this is tricky. So I had to spend some time thinking about it. And one of the things I've learned that's a good mindset is try to remove the most material in your first operation. Now, that doesn't mean it's a steadfast rule, but it's generally the way to go. And I was thinking about this, and I thought, okay, so we've got to machine this big cavity in here, and then we'll have to machine this area up here, and then we'll have to machine this area up here. So I think it's a 3-op part, and that is what I've concluded. But so let's walk through, and folks, this is going to be a little bit of a longer video because I really want to take my time and walk you through how I think we're going to tackle it. And this is really to help you and to help Keith understand how to get started. It isn't necessarily going to be the cam or the code that he runs, but here's the thing, folks, we're going to actually ask you at the end for your help here. Keith has done a lot to give back to the YouTube and machining world, and hopefully this is our chance to give back to him because I'm not sure I'm coming up with the best strategy here. But let me show you what I got. First thing I want to do is right-click, New Component, and I'm going to rename it Stock for the Fusion Friday. But we're going to model up the piece of stock for a couple of reasons. The first is I need to figure out what to buy or what to tell Keith to buy. So I'm going to hit, I'm on that stock component is active. I'm going to hit R for rectangle, and I'm going to click that plane right there. So I can't click it from this view, but if I hold my mouse over that area and then click the left mouse button, the normal mouse button, and hold down, I get this pop-up which gives me a few options. I want that YZ plane, which I don't always remember that it's YZ, but it pops up in the highlight, which is good. So now I'm sketching a rectangle on that plane, and you know what? The problem with a rectangle is it's not really the shape that I want it to. It's kind of oriented the wrong way. So hit Control Z or undo, L for line, and I'm just going to sketch some lines around it. Now don't get hung up on these being perfect, because what I'll do now is say perpendicular. I want this perpendicular to this, this. So now I've got a proper rectangle, right? This should over-constrain it. Yeah, that was more than I needed to do. So I'll go back to select mode. So I can kind of start dragging this around to understand because this is going to be the most efficient piece of raw material to buy. So buying less raw material is good, and less to machine away is good. I want to kind of space it off the part to get an understanding of how big it is. Because right now, if I do D for dimension and click this line, I say, okay, well, we need a 5-inch part. Ooh, is that going to work? I don't think it did, actually. See how it's hard to kind of see? Ooh, actually, that might work. Yeah, that's awesome. D for dimension. I'm actually going to try, D for dimension, If I click on this, see, I can't click on that bottom of that pad or that leg. So we're going to do something called project. Hit the P key on your keyboard, or you can go to Sketch, Project, Project. This is one of the coolest things in CAD. So the reason I can't click on that foot is right now I'm sketching on a plane that you see where this rectangle is. Well, those feet don't exist on that plane. They're over here. And so if we look at it from a side view, I see them, then they're right there. But again, when you start to orient the model around, you see, okay, well, they're not there. But if I click on the bottom of that foot, like so, it projects what will end up being a straight line. Why is it a straight line and not a circle? Because, again, it's only giving me a projection of the intersecting geometry. Does that make sense? It's pretty cool. And it's purple, which means it's linked back to the foot, which is good. If I happen to have changed the foot, it'll update that. Not really a concern here because this CAD model is pretty well done. D for dimension. I'm going to click the bottom of our stock, and I'll click the purple line, and that'll let me say, I want at least 50 thousandths of an inch off of that. And I can now dimension this, and we'll say he'll probably have to buy a 3.5 inch piece of material. Now, the other thing that's really important is I don't remember doing anything to make this square to our part. It might be, and I'm not sure why, but the other thing we could do to make sure of that is parallel between that projected line and our stock. I think it's going to tell me it's over constrained because it already is. So no worries. Now what I'll do is D for dimension. From this point to here, just to kind of lock in that location of that stock so it's all black. Being all black is important because that tells me where our stock isn't going to move. So I've got this rectangle that represents our stock right in the middle of my part. E for extrude. Click on it once. And if I drag this blue arrow now, it's just going to go one way. I want it to go both ways. So I'll change direction to symmetric. And now it's pretty cool. I can just drag it out and take a look. How big do I need it to be? Is 8 inches going to cover it? Looks like it does, actually. I'll click OK. And I can actually right click on this stock, opacity control, say 30%, and I can now see Keith's part inside of that stock. So that should work. So now I know Keith needs to buy an 8 inch by 3.5 by 5 inch piece of, I think he said he's going to use Delrin. Cool. Let's start making some cam chips here. Switch from model to cam. And this was my attempt last night, so we'll start from scratch here. First, I'll click a new setup. And excuse my fusion, I've got some errors here. We're going to change our stock to from solid. And I'm going to pick that stock that we just modeled. So how do I get to it? See right here, this icon, and we'll make this Fusion file available to download. Check the link in the video description. Expand that. Expand the stock FF. Expand the bodies. Sorry, I know it's a lot of expanding. And I click that body. That gives me that stock that we just modeled up. And I like this because if I then need to change the stock size, or let's say Keith is only able to buy a 4 by 5 inch piece, he can update that and it'll flow through here. And again, we're going to machine this underside first. So back in setup here, the first tab, what is my model orientation, or orientation rather? Well, this is the wrong way. I want it pointing up. So if I click the tip of the Z, the blue, that flips it up. And if I now say stock box point, see over here, I'll choose box point, and I would probably pick the top left corner of it. So that looks good. The other reason we're going to machine it this way, and I talked to Keith about this to see if he agreed, is our second and third ops will make, or Keith will make rather, a fixture that we can stick these 4 pins into. We can probably even drill and tap the centers of those And then there's actually some creative things we could do with even like an expanding foam or urethane to help secure and add rigidity to this part after this area is machined away. Keith was talking about making this on his plasma cam, which he has a router attachment for, but it's got ER11 collets, which don't go very big. I think the largest collet size would be 5/16. So when I was playing around with our first operation, which is what we're working on right now, I was really getting frustrated because it was just creating so much toolpath. It was taking so long to compute. And I realized, well, ignore that. That's not the battle we're trying to solve right now. So from a CAM philosophy standpoint, I'm kind of ignoring the realities of the machine for a second. And instead, let's just go 3D, adaptive clearing. And so instead of picking a 5/16 inch flat end mill, which is the biggest tool Keith's going to be able to use, let's get the CAM process nailed down. Let's decide what operations we're going to use and make sure the part gets it done correctly. And then we can come back and we can switch these out to the smaller tools, which take a little bit longer to calculate, and it looks a little bit noisier. It takes longer to simulate because, again, break it down. So 1-inch tool, let's just click OK, see what we get. So why am I getting an exclamation point here? This one is a tough one. I don't know how to tell you to debug this other than to say when I get an error on an adaptive and I'm just like, why is it? That doesn't make sense. Go back to your setup, edit, and take a look at what's in your model. So this is important because this is what Fusion is looking at to decide what to machine. So we want to pick just, see, that's the stock. I don't want that. I want to pick, actually turn the stock off. I just want Keith's part, just that guy. But when I had the stock picked, it thought that was the end product. So it's like, well, if you're giving me stock that's the size of this rectangular block, and you're also telling me that that's the model in the end, well, there's nothing left for me to do. So I just want the model to be this. This is a really common thing we'll see from folks that will reach out to us for help, say even on Patreon, and say, all of a sudden my Fusion doesn't work. Usually they need to come back and check what's selected in their setup model. Click OK. Awesome. I like it. Still a lot of noise, a lot of toolpaths, but had I done a 5/16 tool, it would have been even worse. And that is what Keith's going to have to do. And you know what? That's okay. I love it. I love pushing machines to or past their limit. So let's do a simulation. Click on stock, click play, and kind of just fast forward through. So that first is a true roughing operation. It's going to stair step this down. We can start to see the posts form, but obviously a lot of work left to do. That's okay. So let's do a second adaptive. And this time we'll do 3D adaptive, but this time we'll do the 5/16 tool, which again will probably be the one that Keith has to use the whole time. And I'll just click OK. Sorry, model bottom. Try to get that fixed. So that's no good because look, it's cutting a bunch of stuff that we just cut. So right click, edit, geometry. See this thing called rest machining? Check that and then change it. I wish the default would change by, well, I wish the default would be changed, but you want to switch it to from previous operations. So what is this doing? It's saying only machine the rest of a remaining stock is apparently what rest stands for, not just the rest of the part. Remaining stock from this previous one. So click OK. Now this is going to take longer to compute because Fusion has to look at what happened in the prior operation, but it's also going to create a much fewer toolpaths because there's less material to work with, which is great. Our Wednesday widget this week I thought was a great example of where rest machining really shines. We made this sign and we roughed out the center here with a big 1/2-inch end mill, and then we did a 3/16, which got into the nooks and crannies that the 1/2 couldn't, and then we did a 1/8-inch that got into the smaller, see here, right here, that's more nooks, and then we went down to a 1/16-inch, which is getting into the other remaining stuff. Really cool, smart way to work. So here we've got the 5/16, which is now doing even less work, which is great. And if we just take a look, click on setup, simulate, and I'm just going to click the go to end of toolpath, which is going to fast forward through everything and see where we're at. Awesome. So we can start to see this is looking more like the interior. We still have some stair steps, but we can see the pockets and so forth. So this was really bothering me. I just rebooted my computer because I was thinking, what is wrong? Why am I getting what appears to be a crash or a toolpath that is going through the two legs back here? And it's funny because when I was on the phone with Keith yesterday and we were joking about crashing machines, not in a, not in being a crazy cowboy way, but just, stuff happens. Like, you got to do it. And here's what I was talking about. And you can see right here, the stock is gone and the model is backfilling it. So first off, that's a really good lesson, especially if you're new to Fusion, is when you're using the simulation, is to turn off the light bulb of your model right here. And that's going to show us more easily what the simulation is actually doing. And here, sure enough, it is machining through those two pegs. And I thought, what? How was that doing that? And I spent a few minutes looking at the toolpath, zooming in and trying to figure out. And I thought, man, this must be a graphics glitch because I don't see any blue or yellow line going through there. Now, I was missing one really obvious clue. Anybody know what that is? Take a look. What's the shape of that stock that's showing it's being cut away? It is the shape of the tool holder. So Fusion is actually correct here. And the other way to look at what happened is, let's turn off our stock. And I know it happened toward the end when I'm getting some of these collisions. And sure enough, look at the collision. If I hold my mouse over that little red tick, it says holder collides with stock. So watch, look at that. Go back to tail here and hit play. That's what's happening, is right there, we're machining too deep relative to the shank of the tool, and it's hitting that pin. Great thing to know. Very relevant, and that's how you avoid crashes. So right click on the adaptive, edit, heights, and let's say we've only got 2 inches that we can machine with this part. I'm going to change my bottom height to be model top, which doesn't sound right, with a negative 2-inch offset. Click OK. That's now going to stop it from going too deep and should solve that problem. Regen the toolpath, simulate, show the stock, fast forward through everything. Great. I can now see that's not happening. I like it. This comes back to your tool library though, and how we have our tools set up. So on this 5/16 end mill, let me slow down here. Right click, edit, select the tool, tool 1. I right click, edit tool, I can now see what I've modeled as the flute length and as the shoulder length. So your flute and shoulder, yeah, and then the body length. So normally I would say the flute length is what you can actually cut with, and the shoulder length would be how much basically I would think is sticking out of the tool holder. So I will probably change body length to be 2.3125. And that's going to help. It's really important here for Keith because Keith's going to have a really long stick out, and he's got to be conscious of the tool holder hitting other parts of the model itself. After we're done with these sort of 2 roughing operations, we need to get some 3D surfacing done on the interior of this. And again, folks, I really want to see what you guys come up with this. Am I wrong? Are there better ways to do it? And hopefully we can all learn and take away some tips and tricks. I'm going to go ahead and say 3D scallop, and we'll pick a 5/16 ball end mill. Click OK. And again, with the 3D operations, I tend to just click OK right away and see what they come up with. That differs from the 2D operations, where 2D you have to first tell Fusion like a face or a contour or a line what to do. The 3Ds basically rely on the solid model, and you create exclusion zones, or you click on things to control where it goes. So this isn't half bad. You start to see it's walking all the way around that part. What did I do last night to change it. I think I really just reduced the step over. Let me take a look. Ah, that's right. That's what I did. So one of the easier ways, like I said, 3D toolpaths are all about toolpath containment. It starts with a big toolpath and you do things to reduce the area where it does work. The easiest way, like I said here, is avoid touch surfaces. So I'm going to click that. I'm going to click these 1, 2, 3 faces. And in this case, I don't want to avoid them. I actually want to touch those. I want to do work there. Click OK. I want to eventually reduce my step over. See how wide of a step over that is? We eventually want to have it look more like this, a finer step over, which gives us less scalloping on the part, or it looks smoother. Now this is also the inside of the dash piece, so Keith may not care about it being super smooth, but I would not. I would worry first about getting that toolpath to do what you want and go where you want, and then when you think you like it, under passes, change the step over, say to 50 thou. Click OK. It takes a little bit longer to compute, so that's why I do it at the end. Let's walk through the rest of what I did to finish up the backside of this part. So we did a scallop here. I did basically the same scallop to handle the inside of the gauge cutouts. So under geometry, just selecting all of those faces. Does anybody know, something that bothers me in Fusion is when I go to pick these faces, yeah, that's correct, that's correct, that's correct. But sometimes when you hover to like right here and I click, it does the whole darn body. That's not what I want. Anybody know how to stop it from happening? And then I use a pencil toolpath. So pencil toolpath is awesome for taking, in this case, a 1/8 inch end mill and cleaning up some really tight little areas. And this is one where I, again, welcome input, welcome on some tips to make this better. Let's walk through creating a pencil toolpath. 3D, pencil. If you read that pop-up, it's a great descriptor, too, of what it does. 1/8 inch end mill, ball. And now you've got a really long stick out here, folks. I absolutely want to recognize that a 1/8 inch end mill sticking out 2 inches, that is 16 times diameter. That's the way I think most people talk about it. That is huge problems potentially. Now it's also plastic, and Keith will have a super high RPM, so we'll have to see how he handles that. So geometry, well, here, just click OK. See what we get. This will not be a good toolpath, but again, I'd rather start with something and work our way in. So I'm going to want to focus on this area right here. So let's do geometry, avoid touch, touch, and let's pick this. Click OK. So all we get is this little bit right here. I wanted it to go all the way around like this. What's the difference? Let's just do compare and edit. I'm going to click on the one here that I know is good, so I'll call it pencil good. Hold Control and click on this one. Right click, compare and edit, and I'm going to change this here from all to different, and it's going to walk me through all the settings that I've got that are different. So I know the good one works, and this one doesn't. So additional offset, machining selection, number of step overs, over thickness, step over. Okay, this is a good, you can edit them here. I'm going to walk you through how we edit them back in the normal way, sort of per se. Over thickness is, I think, going to be the key, and that's one that's a little bit tricky. You can spend a lot of time learning the nuances of these 3D toolpaths. Over thickness in pencil relates to basically, I want to machine a radius that's bigger than the tool radius. So in this case, I have a 1/8 inch end mill. I want to machine whatever that is, a 1/4 inch radius or something bigger. So I'm just going to put in some over thickness of 0.3. The other way of saying that is when I use pencil, I usually put in some amount of over thickness and just see what happens. Good. So it's going around. That looks better. Let's do number of step overs. Let's just say 15, and we'll say a step over 0.02. Now it won't do 15 step overs. It'll just do up to 15 subject to the touch surfaces, which is pretty cool. And this is how I learn, folks. You just play around. Yeah, you need to know enough to kind of say what are the important things to do. So I don't mean to make it sound like it's just easy and you just pick it up right away, but you experiment, you play. So look at that. Simulate. Let's take a look at what that does. It comes in, it's going around, walking around there. I don't know why it does a lead in or out there. It shouldn't have to. Cool. Starting to look like a good toolpath, right? Or better. It would be nice if it was not doing all these linking moves in and out. Anybody know how to improve that? If I change the heights, if I change my retract height to be just, say, 100 thou from the top height, I wonder if it'll still move in and out of the cut, but instead of coming all the way up to the top of this post, it'll just come up a little ways. See if that did it. I don't think it did. Nah, it's still coming in and out all the way. You got to be careful playing with your heights too. That is a great example where you can crash. We got a collision warning here. What is it? Rapid collision with stock. That's odd. Oh, you know what it is? There's probably some stock left. I love it. I love learning this stuff. There's probably some stock left when we get to the pencil. Take a look. So I'm simulating up to the pencil. And so sure enough, look, this is what the part should look like on Keith's machine when he starts the pencil operation. Well, there's all this material buildup here that hasn't been cut away yet. So that's really good to know. Maybe we need to do an adaptive in this little area to rough that out before we come in with the pencil. It's Delrin, it might be okay. On the flip side, a 1/8 inch tool that long could have some trouble with it. And if it were aluminum or even wood, you might have a real problem. So, folks, this is a longer Fusion Friday. Let's wrap it there, but we'll do a second part now where we walk through finishing up this Op 1 and then how we move to a fixture in Op 2 and 3. Hope you guys enjoyed. Again, let's do this though. If you want to take a stab at this, link in the video description to download this file. And when you post a YouTube video, please put in the video title, TurnWright 944. That way we can all search it and find it, and feel free to post it on the NYC CNC Facebook page or let us know if you post one because I'd love to learn. I'd love to see how we do this better, and let's help Keith get this thing made. Take care, folks. See you next Friday.